Hi, 7th graders, Miss Opp here. Today we'll be learning about variables and expressions, which is 1-2 in your book. So let's get started. Don't forget, for better understanding, you can always rewatch the video. You could read examples in the book, which is in the blue folder in Schoology labeled Online PDF Textbooks. And you can YouTube the topic to find other teachers' videos. And as always, you can ask questions. Oops, that's hard to see. Questions. What you should be able to say confidently at the end of this video is, I can simplify. We're actually going to be evaluating. Algebraic expressions using the order of operations. That is our target for today. We have some new vocabulary. The first one is variable. We have algebra, algebraic expression, evaluate, numerical expression, order of operations, which we learned the other day is PEMDAS. We have powers, property, and counterexample. Definitions are in your book, and we'll be talking about them throughout the video as well. So just to give you a little bit of organization on some of those new vocabulary words, algebra is the main idea. Numerical expressions look like this. Let me zoom in. 3 plus 2 is a numerical expression. 4 times 9 is a numerical expression. And 6 times 5 squared is a numerical expression. Notice there are no equal signs in a numerical expression. Looking in, a variable is just a letter that replaces a given number. A variable can mean more than just one number, which is why we use a variable. An algebraic expression, a plus 2. So a is a variable that can stand for multiple numbers. 4 times n, another variable, or 6 times x squared. So an algebraic expression uses a variable. And then to evaluate is when we use those algebraic expressions and put that equal sign there and actually do the math. So 3 plus 2 evaluated equals 5. 4 times 9 equals 36. 6 times 5 squared equals 105. So just a couple ways that you can show multiplication in algebra. A lot of times we will see this symbol x used for multiplication, which would look like 2 times n. But there, you can also write it just sitting next to each other, no space. You can show it using parentheses, or sometimes we use an asterisk. Or even sometimes, if you don't want to draw an asterisk, you can just use a dot like that. All of those mean multiplication. So expression, that was one of our new vocab terms. It looks like 7 squared and x to the third. These are exponents, which we learned about in PEMDAS the other day. They are called powers. Powers represent repeated multiplication. So to look, 7 squared, we can classify it as 7 times 7, 7 squared. X to the third power, or x cubed, is shown as x times x times x. Sometimes powers are shown like 7 to the 2, or x to the third. This is simply done just for formatting using a computer. But that all means the same thing as a power. Okay, let's see if we can evaluate some of these algebraic expressions. Looking at this first one, 6 times x minus y squared, if x equals 7 and y equals 4. So the first thing we're going to want to do here is we're going to want to replace x with 7 and replace y with 4. So we'd rewrite, so it would be 6 times 7 minus 4 squared. We're going to perform the operations in parentheses first, which we already know to do because we know PEMDAS. Nope, there's the S. So we go 6 times 3 squared Multiplying that exponent for the e brings us to 6 times 9. And once we evaluate that, we get 54. Looking at another example, evaluate g squared minus 2g minus 4 if g equals 5. So again, we're just going to replace our variables with our numbers. So we're going to make it 5 squared minus 2 times 5 minus 4. We're going to use PEMDAS to remember our order in which we will evaluate. In this situation, we're going to start with our powers. So we got 25 minus 2 times 5. 5 minus 4, which we simplify to 25 minus 10 minus 4, which gives us 11 as our answer. Let's look at one down here that we'll do together. So evaluate each expression if c equals 3 and d equals 7. So looking at A is where we're going to start. Make sure you have your notebooks out and you're following along. We have 6 times c, which is 3, plus 4, minus 3 times d, which is 7. So looking at this, remembering PEMDAS, I know I have to do multiplication first. We got 6 times 3 is 18, plus 4, minus 3 times 7, which is 21. So I know it does not matter which order I do addition and subtraction, so we're going to go 18 plus 4, which is 22, minus 21, which gives us our answer of 1. Awesome. Let's try another example here. We're going to do B. I'm just going to pull it off to the side a little. So we got 4 times d minus 3 in parentheses squared plus 1. I'm going to copy it down and fill in my variables with my numbers. So we got 4 times 7 minus 3 squared plus 1. Oh, that's a plus. Knowing my order of operations PEMDAS, I'm going to do my parentheses first. I'm just going to carry down 4 times 7 minus 3, which is 4 squared plus 1. Next thing I'm going to do is my exponent. So we got 4 times 16 plus 1. The next step is multiplication. So we're going to do 4 times 16, which gives us 64 plus 1 equals 65. If you feel like you need another example, go ahead and do C on your own. And so we got d squared plus 5d minus 6. Go ahead and pause and do that one if you feel like you need a little more help. So another way to show division is a fraction bar, which is this thick black bar right in the center. So let's look at D. To evaluate each expression if P equals 5 and Q equals 12. So I am going to just carry it down and fill it in. So we got 3 times P, which is 5, minus 6, all over, which means we're going to be dividing with our fraction bar, all over 8 minus 5. Knowing PEMDAS, I'm going to do the top first. Let me switch my color pen so it shows up. We got 15 minus 6 all over 8 minus 5. Just working top to bottom. We're going to be doing 9 all over 40. Oops, I stand corrected. That is supposed to be a subtraction. So let's just rewind here and erase that. So we got 8 minus 5, which is 3. That makes much more sense. So we're going to divide it out. 9 divided by 3 equals 3. Do one more division one. We're going to jump over here to F. P is still 5 and Q is still 12. So we got Q squared, so we have 12 squared. in order for myself to remember what all I'm squaring, I am going to put Q in parentheses as you see. That's just so it makes more sense in my head for my organization. Carry down the 4 times P, which is 5, minus 2. Okay, let's go ahead and evaluate this with our order of operations. Exponents first, 12 squared is 144. All over, do multiplication first. 4 times 5 equals 20, minus 2. So we have 144, oops, can't forget my equal sign, 144 all over 18, which gives us our answer of 8. And if you'd like to do another example of a division, go ahead and do E on your own. Just pause the video and do 4Q all over Q plus 2 times P plus 1 in parentheses. Okay, so looking at this, a property is a feature of an object or rule that is always true. So we have 4 properties we're going to be talking about. We have the commutative property, which shows us that order does not matter. If we do A plus B, the answer will be the same as B plus A. For the same way for multiplication. So we go A times B is the same as B times A. So looking at an example of that one, I'm going to zoom in here. We got 6 plus 1. This would equal 7. And 1 plus 6 also equals 7. 7 times 3 equals 21. 3 times 7 also equals 21. So that is the commutative property. Order does not matter. Associative property, that shows us that grouping does not matter as long as it has a common operation. So looking at this one, we got A plus B plus C equals A plus B plus C for addition and multiplication, excuse me. So looking at an example, we have 2 plus 3 plus 8. That would give us, we know we have to do this part first. This would give us 11. Plus 2 would give us 13. But looking at the other way, 2 plus 3, that would equal 5. Plus 8 also equals 13. Looking at it from a multiplication lens, we got 4 times 5, which we know is 20. Ooh, 20 times 3, which would give us 60. Okay, another one of our new vocabulary words right here, counterexample. So state whether the following conjecture is true or false. If false, provide a counterexample. A counterexample is an example that proves it is false. So let's look at number 5 here. Division of whole numbers is commutative. So let's see. So they have in the example 15 divided by 3. That would give us 5. But if the division of whole numbers is commutative, it would be the same 3 divided by 15. 3 divided by 15 is 1/5, and those are not the same. An equal sign with a bar through it means not equal. So we found it to be false, and we found the counterexample because 15 divided by 3 does not equal 3 divided by 15. So that conjecture is false. So we're moving on to I. State whether the following conjecture is true or false. If false, provide a counter example. The difference of The difference of 2 different whole numbers is always less than either of the 2 numbers. So let's try this. So I'm going to pick 8 and 2 as my numbers. So the difference between the 2 numbers, difference always tells us that we want to subtract. So the difference of 2 whole numbers, let's try that. 8 minus 2, that gives us 6 is always less than either of the two numbers. So my smaller number is 2, and my difference was 6. So I'm trying to prove if my difference is less than the smaller of my two numbers. So I'm trying to prove that 6 is less than 2, which we know is not true. So this is a false conjecture because we found a counterexample using the numbers 8 and 2. Awesome, so with that we have reached the end. Don't forget, for better understanding, you can always rewatch the video. You could read the example in the book, or you could YouTube the topic and find other teachers' online lessons. And as always, don't be afraid to ask questions. Questions are the best way to learn. There is a quiz you can take, you are required to take on Schoology, so now you'll go ahead and do that. Happy quizzing!